Titration is a technique that uses a solution of known concentration to determine the concentration of an unknown solution. The solution with the known concentration is called the titrant, and it's placed in a piece of glassware called a burette that accurately measures how much of the titrant we're adding at a time. The titrant is slowly added to a beaker or flask with the unknown solution in it until the reaction is completely neutralized. That's called the equivalence point, when the amount of acid and base added together are stoichiometrically equal, so there's exactly enough to react together without any leftover excess reactants. There's an indicator that's added to the unknown solution in the beaker or flask that changes color when the pH changes. The end point of the reaction is when the indicator changes color, and if the indicator is chosen well, that end point will be the same as the equivalence point. So what we really want is for the indicator to reflect the equivalence point, which is when the acid and base are completely neutralized. So this is what the setup for an acid-base titration looks like. The titrant of known concentration is in the burette that's set up above the solution of unknown concentration with an indicator in it. Now you could do this with a known concentration of acid in the burette and an unknown concentration of base in the beaker or flask below it, or vice versa, with a known concentration of base in the burette and an unknown concentration of acid below it. So it's not always the acid or base that's the titrant, it's just whatever is known as the titrant and whatever is unknown is the analyte. These are some common indicator solutions and their colors at different pHs. The first is bromothymol blue, or BTB, and it's used with a strong acid and a strong base because when a strong acid and base are combined, the equivalence point is neutral, or a pH of 7, and bromothymol blue changes color at a pH of 7. So if we start out with BTB in the acid, the solution will be yellow and it will change from yellow to blue at the equivalence point when the acid and base are neutralized. And if we start out with it in the base, the solution will change from blue to yellow at the equivalence point. So BTB is a good indicator for a strong acid and a strong base because it changes color at the same pH that the acid and base are neutralized. Methyl orange is used with a strong acid and a weak base because the pH of a strong acid and a weak base at equivalence is below neutral, and methyl orange changes color at around a pH of 5. So the solution will change between red and yellow at the equivalence point when the acid and base are neutralized. Phenolphthalein is used with a weak acid and a strong base because the pH of a weak acid and a strong base at equivalence is above neutral, and phenolphthalein changes color at a pH of around 9. So the solution will change between colorless and pink when the acid and base are neutralized.